Hello students, welcome back. So we are doing logarithms exercise 8D from ICSE book of class 9, isn't it? And in our previous videos we have completed till question number 10, and today in this video we'll start right from question number 11 onward. Okay, so let's begin. This is question number 11 from exercise 8D. If log x plus y to the base 2 equals to log x minus y to the base 3 equals to log 25 upon log 0.2, find the values of x and y. So these are the equations given to us. We are asked to find the values of x and y. Okay, suppose if a equals to b equals to c, okay, which means the values of a, b and c are equal to each other. So we can write this as a equals to c and b equals to c, isn't it? If a, b and c are equal to each other, then we can write a equals to c and b equals to c. Okay, similar thing, this equals to this equals to this, isn't it? This means this equals to this and this equals to this. Okay, we are going to make two equations because we are asked to find the values of two variables, isn't it, x and y. So we need two equations. Okay, now first is log x plus y to the base 2 equals to log 25 upon log 0.2. okay, or this is first and the second is this equals to this. We will do that later on. Log x plus y to the base 2 equals to log 25, okay, log 25 upon log 0.2 means log 2 by 10, isn't it? So 2 1s are 2, 2 5s are 10, or log x plus y to the base 2 equals to log 25 to the base upon log 1 upon 5, isn't it? So log 1 upon 5 means log 1 minus log 5, okay, or log x plus y to the base 2 equals to this log 25 can be written as log 5 squared upon log 1 means log 1 to any base is always 0. Okay, log 1 to any base is always 0. So there is no base here, means base is 10. Log 1 to the base 10 means 0 minus log 5. Okay, log 5. Now, or log x plus y to the base 2 equals to log 2 log this 2 comes in the front, isn't it? 2 log 5 upon 0 minus log 5 is minus log 5, isn't it? Minus log 5. So we can cancel this log 5 and log 5 from the numerator and denominator. We have minus 1 in the denominator. Okay, so we take this minus sign to the numerator, or you can write this as log x plus y to the base 2 equals to this minus we bring to the numerator, minus 2. Okay, if we have minus in the denominator, we must bring that minus to the numerator. Okay, that becomes minus 2, plus 2 into minus 2. Okay, and in the denominator we have 1, we need not write that. So we have log x plus y to the base 2 equals to minus 2, isn't it? Which means this is a logarithmic equation. Now let us convert this equation into exponential form. Okay, so how do we do that? 2 is the base here, isn't it? Or 2 is the base here, 2. This minus 2 comes here as power, minus 2 equals to, now this x plus y goes to the right hand side, equals to x plus y. Okay, this is how we convert logarithmic equation to exponential form. This 2 is base, we write here as base, this minus 2 comes here as power, and x plus y goes to the right hand side. Or let us bring this x plus y to the left hand side, equals to 2 to the power minus 2 means 1 upon 2 squared, isn't it? Minus 2 goes to the numerator and becomes plus 2. sign of the power changes when we take number from the denominator to numerator or numerator to denominator, okay? Or x plus y equals to 1 upon 4, isn't it? So this is equation 1, okay? X plus y equals to 1 upon 4. Now we will solve this 2 and find equation 2, okay? Now, and we have log x minus y to the base 3 equals to log 25 upon log 0.2, isn't it? Log 0.2, or log x minus y to the base 3 equals to, this whole thing is actually minus 2, isn't it? We have already solved this. This equals to minus 2. Log 25 by log 0.2 is minus 2. So you can write this whole thing as minus 2, okay? Now let us convert this logarithmic equation to exponential form. So 3 is the base here, we write 3 here. This minus 2 comes here as power, equals to x plus y goes to the right hand side. Sorry, x minus y. Now we bring this x minus y to the left hand side. X minus y equals to 3 raised to power minus 2. We take down the number and the sign of the power becomes positive, okay? Or x minus y equals to 1 upon 3 square means 1 upon 9. This is equation 2. So we have equation 1, x plus y equals to 1 upon 4, and equation 2, x minus y equals to 1 upon 9. Now let us solve these two equations to find values of x and y, okay? So please take the screenshot. I'm going to erase this. Now we have x plus y equals to 1 upon 4. This is equation 1. And x minus y equals to 1 upon 9. This is equation 2. Adding equation 1 and 2 we get, this is simultaneous equation, isn't it? So adding 1 and 2 we get plus y and minus y gets cancelled. This is plus y, this is minus y, becomes 0. X plus x, 2x, okay, equals to 1 upon 4 plus 1 upon 9. 1 upon 4 plus 1 upon 9, isn't it? So, or 2x equals to 4 and 9, LCM is 36, isn't it? So 4 9s are 36, 9 1s are 9, plus 9 4s are 36, 4 1s are 4, isn't it? Or x equals to 9 plus 4 is 13 upon 36 into this 2 comes down to the denominator, isn't it? 2, this 2 is cross multiplied to the denominator, okay? So 36 into 2 you can write straight away as 72, okay? 13 upon 72. So this is a proper fraction. X equals to 13 by 72. We need not change that. Now let us find the value of y, putting the value of x in equation 1 either or equation 2, okay? So putting the value of x in equation 1, putting the value of x in equation 1, you can put the values of x in equation 1 or equation 12. Whichever way you find easier, you can do that, okay? X plus y equals to 1 upon 4. Now the value of x is 13 upon 72. Instead of x, I write 13 upon 72. Plus this y we write here equals to 1 upon 4, isn't it? Now I will erase this, okay? Or we keep y in the left hand side and take this number to the right hand side, okay? Or y equals to, we have 1 upon 4 already in the right hand side, 1 upon 4. Now let us take this 13 upon 72 to the right hand side, becomes minus 13 upon 72. Or y equals to the LCM of these two numbers, 4 and 72. 2 2s are 4, 2 3s are 6, 7 2 6 are 12, 2 1s are 2, 2 18s are 36, isn't it? So 2 2s are 4, 4 8s are 2 2s are 4, 4 8s are 32, 4 1s are 4 plus 3 is 7, 72. The LCM is 72, okay? So 4 into what number gives us 72? 4 into 18 gives us 72. 18 into 1, 18, minus 72 into 1 gives us 72. That 1 into 13 is 13, okay? Or y equals to 18 minus 13. 8 minus 3 is 5, isn't it? So 1 minus 1 is 0. we need not write that. So 5 upon 72 is the value for y. Okay, so we were asked to find the values of x and y, isn't it? So x equals to 13 upon 72 and y equals to 5 upon 72. So these two are the values of x and y. I hope you got this. Now let us move on to the next question. Let us do question number 12. Okay, log x upon log y equals to 3 upon 2. This is one equation and this is another equation. Log xy equals to 5. So we are asked to find the values of x and y, isn't it? So let us solve this. So before we solve this, let us first see the rule. Okay, if we have log a upon log b, then we can write this as log a to the base b. Okay, log a upon log b can be written as log a to the base b. Now this we can write, since first let us copy this condition. Okay, equation, log x upon log y, isn't it? So 3 upon 2. Now log x upon log y, this is the rule. Okay, laws of logarithm, we have already completed this. You can find out the video. Okay, log x upon log y can be written as log x to the base y. Log x to the base y equals to 3 upon 2. Okay, equals to 3 upon 2. Log x to the base y equals to 3 upon 2. Now this is a logarithmic equation, isn't it? Now let us convert this equation to exponential form, or y is the base, isn't it? So y, this 3 upon 2 comes here as power raised to power 3 upon 2 equals to this x goes to the right hand side. So x equals to y to the power 3 upon 2, or x equals to y to the power 3 upon 2. Okay, this is equation 1. Now let us solve this. Log xy equals to 5. Since log xy equals to 5, now we don't have base here, isn't it? We can assume the base is 10. If the base is not given, so we must assume the base is 10. Okay, so 10 is the base here. So let us convert this logarithmic equation to exponential form. 10 raised to power 5 equals to xy. Okay, 10, this 10 is the base, so 5 comes here as power equals to xy. Now we have the value of x is y to the power 3 upon 2, isn't it? So, or xy equals to 10 to the power 5, isn't it? Xy equals to 10 to the power 5. Now we put the value of x from equation 1. Okay, value of x from 1, putting the value of x from equation 1. So x into y, isn't it? X into y gives us 10 to the power 5. X is y to the power 3 by 2. So y to the power 3 by 2, y to the power 3 by 2 is x into y equals to 10 to the power 5. So y into y, same base, means we have power 1. Same base means we add up the power. Y to the power 3 by 2 plus 1 equals to 10 to the power 5. Or y, if the bases are equal, y, we add up the power when we multiply, isn't it? This we learned in the laws of indices. Okay, so the LCM of 2 and 1 is 2. So 2 1s are 2, 1 into 3 is 3, plus 1 into 2 is 2. So 2 into 1 is 2. Okay, equals to 10 to the power 5. Or y to the power 3 plus 2 is 5 by 2, isn't it? 3 plus 2 is 5 upon 2 equals to 10 to the power 5, isn't it? So what we do is we multiply the power by 1 upon 5, okay, in the left hand side and the right hand side, equals to 10 to the power 5 into 1 by 5. You see, we are multiplying the power by 1 upon 5, 1 upon 5. Now this 5 and 5 can be cancelled, this 5 and 5 can be cancelled. So y to the power 1 by 2 equals to 10 to the power 1, means 10, isn't it? So 1 upon 2 is the root, isn't it? When we take this number to the right hand side, becomes a square, okay? Or y equals to 10 square. This is 1 upon 2. 1 upon 2 means root. X to the power 1 upon 2 means root x, okay? A to the power 1 upon 2 means root a, okay? So 1 upon 2 is root under y. So root, when we take to the right hand side, becomes a square. So y equals to 10 square. That means y equals to 10 square is 100. 10 10 is 100, isn't it? So we found the value of y. Now putting the value of y in equation 1 either or 2, we can find the value of x, okay? So equation 1. Putting the value of y in equation 1. Putting the value of y in equation 1. So equation 1, x equals to y to the power 3 upon 2. Y to the power 3 upon 2, isn't it? Or x equals to, what is y? Y is 100. 100 means 10 square, isn't it? 100. First let me write 100, okay? Y means 100. Oh, y means 100 to the power 3 by 2, isn't it? Or x equals to 100 means 10 squared. 100 means 10 squared, 10 10 is 100, into this 3 by 2 we write here, okay? Now this 2 and this 2 can be cancelled. Therefore x equals to 10 cube. 10 cube square, 2 cancelled. Now 10 cube. 10 cube means 1000, isn't it? 10 raised to power 3 means 1000. Therefore x equals to 1000 and y equals to 100, okay? So we were asked to find the values of x and y. The values of x and y are 100 and 1000. 1000 and 100, okay? I hope you got this. Now let us move on to the next question. Let's do question number 13 from exercise 8D. Given log x to the base 10 equals to 2a and log y to the base 10 equals to b upon 2. These two are the given conditions, okay? So question number 1 of 13, write 10 to the power a in terms of x. So we are asked to write the value of 10 to the power a in terms of x, okay? So we need 10 to the power a, isn't it? So we will see this equation, okay? Since given condition is log x to the base 10 equals to 2a, isn't it? This is the given equation. Now we convert this logarithmic equation to exponential form. So this is 10 base 10 to the power 2a equals to this x we take to the right hand side. Now this is converted to exponential form, okay? Or we need 10 to the power a, isn't it? Only 10 to the power a, but we have 10 to the power 2a here. So let us divide the power by 2, okay? Both sides. 10 to the power 2a upon 2 equals to x to the power 1 upon 2. So we don't have the power here, means the power is 1. So 1 upon 2. So dividing the power by 2. This means 2 and 2 cancels, or 10 to the power a. We need 10 to the power a, isn't it? 10 to the power a. So 10 to the power a equals to x to the power 1 upon 2. X to the power 1 upon 2 means root under x, okay? So this is what we are asked to find. 10 to the power a in terms of x. 10 to the power a means root x. I hope you got this. Now let us move on to the next question. 10 to the power 2b plus 1. Now we need this equation, okay? Since b is there, isn't it? Log y to the base 10, y to the base 10 equals to b upon 2. Or base is 10 here, so we convert this logarithmic equation to exponential form. Base is 10, so we write 10 here. This b upon 2 comes here as power, b upon 2 equals to this y goes to the right hand side. This has been converted into exponential form, isn't it? Now we need 2b plus 1, isn't it? So let us multiply the power by 4, okay? First 10 b upon 2 into 4 equals to y into 4. 1 into 4 is 4. Okay, so 1, the power of y is not given, means 1. 1 into 4, 1 into 4 is 4, isn't it? Or 2 1s are 2, 2 2s are 4. We have 10 to the power 2b. 2 into b is 2b equals to y to the power 1 into 4 is 4. But we need 10 to the power 2b plus 1. We have 10 to the power 2b. Now let us multiply both sides of the equation by 10. Okay, or 10 to the power 2b into 10 equals to y to the power 4 into 10. Or the power of this 10 is not given, means 1. Since 10 and 10 base are equal and there is a multiplication sign in between them, that means we need to add up the power. 10 to the power 2b into 10 to the power 1 is 10 to the power 2b plus 1 equals to 10, we write in the front, y to the power 4. Okay, so we were asked to find the value of 10 to the power 2b plus 1. 10 to the power 2b plus 1 equals to 10 to the power 10 into y to the power 4. So this is question number 1 and 2. Now let us do question number 3. Okay, this is question number 3 of 13. Conditions are log x to the base 10 equals to 2a, log y to the base 10 equals to b upon 2, and log p to the base 10 equals to 3a minus 2b. So we are asked to find p in terms of x and y. Express p in terms of x and y. Okay, so let us write the given equation first. Since log p to the base 10 equals to 3a minus 2b, isn't it? Now let us convert this logarithmic equation to exponential form. Okay, so base is 10, we write 10 here. This 3a to the 3a minus 2b comes here as power, 3a minus 2b equals to p goes to the right hand side. Now p equals to 10 to the power 3a, 10 to the power 3a minus 10 to the power 2b, isn't it? That means 10 to the power 2b. Okay, upon 10 to the power 3a minus 2b means number goes to the denominator, isn't it? We have learned this in indices. Now if we take this number to the numerator, sign of the power changes to minus, so 3a minus 2b, isn't it? So p equals to 10 to the power 3a upon 10 to the power 2b. Okay, p equals to, you can write this as 10 to the power a into 3. 10 to the power a into 3, isn't it? 10 to the power a into 3. Okay, so 10 to the power 2b, we write as it is, 10 to the power 2b. Or p equals to 10 to the power a means in question number 1 we have found 10 to the power a equals to x to the power 1 upon 2 root x, isn't it? 10 to the power a means x to the power 1 upon 2. So 10 to the power a is x to the power 1 upon 2. You can see question number 1 of question number 13. Okay, 10 to the power a means x to the power 1 upon 2 whole cubed upon 10 to the power 2b is given to us. 10 to the power 2b equals to y to the power 4. 10 to the power 2b equals to y to the power 4. Y to the power 4. Okay, so let me continue here. P equals to, now x, so this 3 is in the numerator, so 1 into 3, 3 upon 2, 2 is in the denominator, upon y to the power 4. Okay, so this is the value of p. So we are asked to find the value of p in terms of x and y. So value of p is x to the power 3 upon 2 upon y to the power 4. Okay, now let us do question number 14. Okay, let us do question number 14 from exercise 8d. Solve log x plus 1 to the base 5 minus 1 equals to 1 plus log x minus 1 to the base 5. So this is the equation given to us. We are asked to find the value of x. Solve means we are asked to find the value of x. Okay, so let us bring this log to the left hand side and take this minus 1 to the right hand side. So we already have log x plus 1 to the base 5 in the left hand side. Now we bring this number to the left hand side, minus log x minus 1 upon to the base 5 equals to 1 is already in the right hand side. Now we take this minus 1 to the right hand side, becomes plus 1. Okay, now we know that if log a minus log b, okay, same base, x, base must be same. Okay, log a to the base x minus log b to the base x, we can write this as log a upon b to the base x, isn't it? So log x plus 1 to the base 5 minus log x minus 1 to the base 5, we can write this as log x plus 1 upon x minus 1 to the base 5, okay, equals to 1 plus 1 is 2. Now this is a logarithmic equation. Let us convert this equation to exponential form to find the value of x. So base is 5, so base we write here like this, and this 2 comes here as power, equals to x plus 1 upon x minus 1 goes to the right hand side. Okay, so 5 squared is 25, 25 into x minus 1, cross multiplication, x minus 1 equals to x plus 1, or 25 into x is 25x minus 25 ones are 25. Let us bring this x to the left hand side, minus x equals to 1 is in the right hand side. Okay, this x we brought to the left hand side and minus x, this 1 we left in the right hand side is plus 1, or 25x minus x is 24x. Now we already have 1 in the right hand side, let us take this minus 25 to the right hand side, plus 25, or x equals to 1 plus 25 is 26 upon 24, isn't it? So 2 12s are 24, 2 13s are 30, 2 13s are 26, isn't it? So x equals to 12 whole, 1 by 12, 12 ones are 12 plus 1 is 13 upon 12, okay, 13 upon 12, 12 ones are 12, 13 minus 12 is 1, this 1 we write here, this remainder we take to the numerator, 12 we bring down to the denominator, 1 whole 1 by 12. Since this is an improper fraction, we convert this into mixed fraction. Okay, so the value of x, we were asked to find the value of x, x is 1 whole 1 upon 12. I hope you got this. Now let us move on to the next question, 15. Let us do question number 15. Solve for x. If log 49 to the base x minus log 7 to the base x plus log 1 upon 343 to the base x plus 2 equals to 0. So this is the given equation. So we are asked to find the value of x, isn't it? So these two are positive. Positive means what we do is log a plus log b, if the bases are same, okay, x or 10 10, whatever be the base but same base, then we write this as log a into b, that is ab to the base x, isn't it? So these two are positive. This means, or log 49 into 1 upon 343, 1 upon 343, like a log a plus log b is log a into b, isn't it? A into b to the base x, okay, base is x. Now this minus log 7 we write here, log 7 to the base x equals to plus 2 we take to the right hand side, minus 2, or log to the base x, 7 7s are 49, 7 4s are 28, 7 9s are 63, 7 1s are 7, 7 7s are 49, isn't it? So 1 is in the numerator and in the denominator we have 7, 1 upon 7 minus log 7 to the base x equals to minus 2. Now this is log a minus log b, isn't it? So if we have log a minus log b to the same base, okay, base are equal, then we can write this as log a upon b to the base x. If we have plus sign we write into, if we have minus sign we write upon, okay. So log a minus log b can be written as log 1 upon 7 upon this 7, okay, to the base x, whole upon 7, log a upon log b, this 7 comes here, equals to minus 2, or log 1 upon 7 7s are 49 to the base x equals to minus 2. Now this is a logarithmic equation, we convert this into exponential form, okay. So x is the base here, x raised to power minus 2, this minus 2 comes here as power, equals to 1 upon 49, 1 upon 49, isn't it? So x to the power minus 2 means 1 upon x square equals to 1 upon 49, isn't it? Equals to 1 upon 49. This means we apply invertendo, okay? X square comes in the numerator, 1 goes down to the denominator. Same thing must be done in the right hand side. 49 comes to the numerator, 1 goes down to the denominator. Or x square equals to 49, okay? X square in the numerator, 49 in the numerator. Now we take this square to the right hand side, x equals to root under 49, isn't it? Therefore x equals to root under 49 means 7, isn't it? 7 7 is 49. So we were asked to find the value of x. The value of x is 7. Okay, this was for today. I hope you got this. Thank you so much. Stay connected, okay, and practice well. I'll upload the rest of the questions in the next video.